Hey, hello, welcome back to our class. I'm going to talk about the earth, the origin of the earth. So, our class today, we are going to talk about the earth. So, let's start from the origin of the earth, whereby the earth is a star with a greater gravitation pull that passed near the sun, and it attracted large quantities of gaseous materials from the sun. The materials split, they cooled, and then condensed. The heavier materials collected at the center. They collected at the center to form the core. So the less dense materials collected around the core to form the mantle. And then the lightest materials formed what? The crust. So this is the shape of the earth, how it looks like. And remember that the earth is not circular. We say that the shape of the earth is geoid. We can say it is void, ovoid, and then we can say it is like an oblate. Yeah, the oblate spheroid, because it is very imperfect sphere. It's an imperfect sphere. So being an imperfect sphere, we can say that it is not circular. And then you remember that it's wide at the equator and the flat at the poles. So that is the shape of the earth actually. It's just a structure. It's just a structure. Uh-huh. So I want to go next point whereby I want to look at the proofs. I want to emphasize on some major points that proves the earth is very spherical. So number one, if one moves towards the east in a straight line, he will end up where he started from. Even or let's say an example, if you use a plane to go eastwards in a straight line, you will end up coming to where you started from. Another point is that the satellite photographs taken from space, they show that the Earth is spherical. And then we can say another point: the places in the east, they usually see the sun earlier than those in the west. Another point where we have all planets are spherical, so the Earth is also spherical, being one of the planets. We can say another point: the Earth's horizon appears curved when observed from a very high point like a tower. So let's talk about the size of the Earth. Actually, the diameter of the Earth is 12,756 kilometers. The equatorial circumference is 40,085 kilometer, and the polar diameter is 39,995 kilometer. And also remember that the water surface that is contained in the earth is at a percentage of 73%. So up to this point, I hope that I've not left any person behind, and I hope that everybody is following. So the movement of the earth. So we have under the movement of the earth, we have two movements, whereby we have rotation and revolution. Whereby rotation of the earth, it refers to the movement of the earth on its own axis. So it rotates through 360 degrees, and it takes 24 hours to complete one rotational. So rotation also, remember that it moves in an anti-clockwise direction. So that is from west to east. The effect of rotation we have, it creates day and night, because at any point, one time, one side of the earth faces the sun, and at the other point, and the other side remains facing the dark side. Kakiwa. Now we have it causes deflection of winds and ocean currents, and that is the hemisphere to the left, and that the hemisphere in the north, and then the left and the other southern hemisphere to the right. And remember, it causes rising and falling of the ocean tides. And then it causes time difference between longitudes, since it takes 1 hour to go through 15 degrees and the 4 minutes to go through 1 degree. So I want to talk about the calculation of the local time, whereby I want to go direct and explain. So let me take an example. Remember that time is gained towards the east and lost towards the west. And remember that I want to now to emphasize on this. I want to give an example that uh, the best formula we can say is that 1 degree is equals to 4 minutes. Whereby we want to take an example. Suppose the time at Greenwich Meridian is 12 noon. What is the local time at Watamu, which is 40 degrees to the east? As I have said, 1 degree is equal to 4 minutes. So what about 40? So you will do what we call cross multiplication, whereby you take 1 degree equals to 4 minutes. What about 40 degrees? So it will be 40 times 4 over 1. That will be 160 minutes, which is equivalent to 2 hours 40 minutes. So the local time at Watamu now we will take, because we said time is gained towards the east. Now we will take the 12. We will take 12 plus the 2 hours 40 minutes. We find that it is now 2 p.m. It will be 2:40 p.m. So that is a good example. So the other examples, you will work them during your free time, and I'll give you some problems that you are going to solve concerning the local time, and I could like to get the feedback during the next class. So let's move to the calculation of longitude, whereby the calculation of longitude is whereby maybe an example we say what is the longitude of place X, whose local time is 8 a.m. when the local time at Greenwich Meridian is noon. So we will take our difference. The difference will be now 12 minus 8, whereby we will get 4 hours. And then we said 1 degree is equals to 4 minutes. So let's convert. If 1 minute is if 1 hour is equal, if 1 hour is equal to 60 minutes. 1 hour is equal 1 hour is equals to 60 minutes. What about 4 hours? So we will take 1 hour is equals to 60 minutes. What about 4 hours? So we will do what we call a cross multiplication, or we can say maybe 1 hour is equals to 15. 1 hour is equals to 15 degrees, whereby we will take now 4 times 15 to get 60 degrees. Now X will be behind by 60 degrees west. I want to talk about the standard time zone, whereby the standard time zone is recorded by countries within the same time and the same zone. So the world has 24 hours zones, and remember that the effect of crossing it is that one gains time when he crosses it from west to east and has to adjust the clock ahead by 24 hours. One loses time when he moves from east to west and has to adjust the time backwards. So I want to talk about revolution of the earth, whereby it is the movement of the earth in its orbit around the sun. So it moves in what we call anti-clockwise direction. The orbit of the earth is called elliptical. The orbit of the earth's revolution is elliptical. And remember that the earth moves 365 and a quarter days, whereby it moves 366 days when we have what we call a leap year. So the sun moves from the tropical of Cancer to the equator, and then towards the tropic of Capricorn and back to the tropic of Cancer. So having looked at these points, let me talk about the effects, and I will stop there so that you will go and do research on the instruments used. I could like to explain about the effect and then stop at that point so that you can go and do research on the structure of the earth. So I would like to start from there in our next class. So let me talk about the effect of a war of revolution, whereby it causes what we call the four seasons, that is summer, autumn, winter, and spring, due to the movement of overhead sun causing changes in the heat belt. And then it causes variation of day and night due to the Earth's axis being inclined to the path of revolution at an angle of 60 degrees. So we have equinoxes. This is what we call how we have equal lengths of day and night. That's equinoxes. We have summer, we have longer days and then shorter nights. We have winter, we have that is longer nights and shorter days. So it causes changes in the altitude of the midday sun due to the earth's orbit. So under the structure of the earth, I would like to stop here. This is structure, so that in our next class I would like to pick from there. I want you to go and study this structure, have a clue on it, so that when we meet in the next class, it will be very easier for me to maneuver across the structure, explain well, and then proceed. So thank you very much for your time. Uh, let's meet in our next class. Thank you.